what I have here is a wire, and with alligator clips on the end so I can connect it to things. And what you can't see is that inside this red plastic insulation there is a copper wire in there, and many of the electrons in that wire are wandering about aimlessly inside the wire. That motion does not constitute a current per se, but if I hook this up to a voltage source, then the electric field from that voltage source will in fact push the electrons that are able to move, will push them in the same direction, and then I will have a current. Okay, but if I have a current in here, I have moving charged particles, and what that means is that I will also have a magnetic field, and the magnetic field will take on the shape of circles. And so you'll have a circular magnetic field here, and the field lines will just be circles further and further out. Of course, the field gets weaker as you get further away, and this essentially will have a magnetic field. And so what that means is that I can bring in another wire and do that, and if I have two wires running parallel to each other and they have current in them, then they will behave like magnets. There'll actually be a slight pull, or repulsion, or attraction because of the magnetic fields. The two wires will actually have an impact on each other. Anyway, the magnetic field around here is not particularly strong unless you have extraordinarily high currents, and so it's not of particular use, but I can have this kind of a wire. Now this is actually an extraordinarily long wire that has been wrapped around into a coil. This coil is sometimes called a solenoid, and the coil is connected here and here. And so what I'm going to do is I'm going to hook this coil up like this to a voltage source. In this case, a pair of batteries. And when I hook this up, it will become a magnet. It will be an electromagnet. So let me hook that up. There we go. Voila, an electromagnet. Now, of course, you can't tell that it's a magnet unless I bring in, as I did with the permanent magnet, something like a compass that will react to this. So I'm going to disconnect this first, and I'm going to lay the compass here. The compass right now is responding to the Earth's magnetic field. You know, the Earth is a big magnet, and it has a magnetic field as well, and that's what the compass is responding to right now. But as soon as I connect these two batteries, I can get the compass to respond instead to this magnetic field. Boom, just like that. There we go. That was pretty dramatic. And I can do the same thing I did with the permanent magnet. I can take the compass and move it around and have it follow the magnetic field, and the magnetic field will be a series of loops that go around and around outside around this coil. Okay. Now the interesting thing here is that I now have access to the interior here, so I can actually follow the magnetic field inside. There's a fairly strong magnetic field in there, and in fact, one of the uses of a solenoid is that I can put a magnet inside here, and the magnetic fields will influence each other, and I'll get a repulsion like that. So the solenoid can push this magnet right out, and this can be used, that force can be used to activate something, position an object. It's a very common device. Like for instance, if you have a doorbell, you might set up a bell over here. Like for instance a doorbell, there are some doorbells where you have a bell and you position the bell here. Let's see if I can get this to work right. I position the bell here, and when you press the button it activates the solenoid, bing, and it rings the bell. So you can do that. Of course, if I flip this magnet around, then it goes the other way. It gets attracted and it actually just gets pulled in to the solenoid.